Now I've already hinted to this next part when we did e to the x and we did our sine ones. So if we go back and look at when we did sine, I added the k in there already as the first time and said, well, when you have done that originally, you would have had a chain rule and had to multiply by k. So when you integrate, you need to divide by that value. And same thing when we did e to the x. I put a k in there and said, well, when you would do the derivative, you'd have to do a chain rule and multiply by that k. So when we integrate, we have to divide by k. And these next ones that we're going to do right now have the same thing, but they have an extra number added in there. But the same thing happens. What happens when you do the chain rule here? Everything stays the same. Bring the 7 in front, 5x plus 3 to the 6, and then you'd have to just multiply by 5. That extra adding 3 didn't make a difference. Same thing with natural log of 4x plus 7. If you took the derivative, you would do 1 over 4x plus 7, and then the chain rule would say you need to multiply by 4. And in all of these ones, the same thing happens over and over again. We have a chain rule where we always multiply by whatever's in front of the x, and having that extra number added or subtracted there is not going to matter. Is this one going to be positive or negative? Positive. And this one will be negative. So if we did all of those ones with numbers, and then we looked at, well, what happens if we just replace those numbers with letters, and I do the derivative of this? Well, the 3 would come out in front. This would stay the same. I'd subtract 1 from the exponent, and then I'd have to multiply by a. Can you see that this pattern's going to happen over and over again? We're going to do our derivative like we would normally, then have to multiply by a because of the chain rule. Do our derivative like normal, then have to multiply by a. And so on and so forth. And a is just some constant number. So because we have to do this over and over and over again, the idea is, well, if we were working backwards, if when we did the derivative we always had to multiply by a, when we're working backwards, we're going to need to find out that we're going to have to divide by a. So now we're going to look at each of the ones that we've done so far and say, if we had a function inside that's basically a line in the form y equals mx plus b. If we have that, we're going to have to divide by that number in addition, because there would have been a chain rule to begin with. So here, our first one, we're going to find the indefinite integral with the power rule. So with the power rule, we add 1 to the exponent and divide by that. We've done that already, but now we're going to have to divide by a as well, whatever that value is, because there would have been a chain rule. So looking at this, if I add 1 to my exponent, I'll get 4/3. So we're going to have to divide by 4/3 as well. But then if you had done this derivative, after you would have done the derivative, you would have had to multiply by 5 in the end. So in order to compensate for that, we're going to have to divide by 5 as well. And then you still have to remember to add c just like before. So now just to simplify this, we're going to be dividing by 20 over 3, so multiply by the reciprocal. Which will give you 3/20 plus c. Yeah. So I'm going to get you to work through the next one and then read the next two examples with e to the x and natural log of x and work till the end of the page. And we'll put up those answers in a bit. You did on these. So this first one, we're finding the integral, and I'm going to change this 9x minus 1 to the negative 8. So when I add 1 to the exponent, and then you'd also have to divide by 9. So we get 9x minus 1 to the negative 7th over negative 63 plus c. So we're doing our derivative rules like we did before. Add 1 to the exponent. Okay, did anybody get negative 9 when they added 1 to the exponent? You don't have to admit to it, but you can, because it's going to happen. You're so used to doing 8 plus 1 is 9 that when you get to negative 8 and add 1, you're going to want to write negative 9. Just be careful with that. And now we also have to divide by the 9 because of the chain rule. For the next ones, we've got our natural log and e to the x. So to be able to recognize this, first of all, as a 1 over x graph. So again, that's where if you can simplify things and say, this is a 1 over x. I ignore the negative 5, I ignore the 3 temporarily, and I recognize a 1 over x with transformations and things changed to it. Then I can do my derivative, or my integral. 15 natural log of 3x minus 5. And then because of that 3, there'd be a chain rule. So to compensate, you'd have to divide by 3. Remember to add c, so we're going to get 5 natural log of 3x minus 5 plus c. Again, this one looks scary because it's got fractions, but again, to be able to recognize, hey, this is just an e to the x graph. So my integral of that, nothing's going to change. But there would be a chain rule, and I'd have to multiply by negative 3, so to compensate for that, divide by negative 3 plus c. And if you turn the page, the last two examples are the same things with sine and cos. Hard part you're going to have to remember is this one where I'm going to have to use a negative. Yes, it is. And here, we're going to divide by 6. See, even when I was making the notes, get myself mixed up with which one. And finally, last example that we're going to do for today. Integrating this one. This one's going to stay negative. And plus c at the end. Well, if the derivative from sine to cos is positive to positive, right? Then it'll go from, if one's negative, the other one will be negative as well. It'll stay the same. So if you're going derivative from sine to cos, whatever the signs are, stay the same. So working backwards from cos to sine, that's going to stay the same as well.